Zeus Kerravala here from ZK Research, and I'm here to do another ZK tour. This time I'm inside the expo hall at VMware 2023. Edge has been a big focus at this show this year, and I'm going to go in the expo hall and take a look at all the different use cases VMware has for Edge, including that cool Ford F-150 that you see behind me. So I hope you enjoy the use cases, and I hope you enjoy this tour. All right, well, I'm here with Chris Lee. You're a product marketing manager at VMware, that's correct?
That's correct,
Yeah,
yes.
you're working the Edge business unit.
Yes.
Okay, so in Sanjay Upal's keynote yesterday, and actually on main stage, they talked about one of the major announcements here was the Edge Orchestrator, right? And
yes.
the software-defined Edge. So what are we looking at here though? We've got a pickup truck, which people don't really think of as a branch office, but I guess could be. We've got some screens up showing us a bunch of the cool technology. So explain how that Edge vision fits into this pickup truck.
Okay, so what we have today is a demo of a police officer truck. So in the back of the truck, usually you have about 100 pounds of equipment.
A lot of equipment.
A lot of equipment.
Yeah.
If you can see, there's a lot of cabling that goes in it, and that's going to be a challenge for the department to deploy this kind of solution, because they have a lot of equipment in the back of the truck. They have 5 or 6 different LTE connections, because every piece of equipment needs that connection. So what we're having here is trying to consolidate all that hardware together and virtualize all the software to run on a single piece of hardware.
So this picture that I'll show on screen, that you see on screen now, that actually is in connected vehicles.
That's right. This came from a police department in the UK, and they had, again, a lot of equipment in the back of the truck, and we virtualized them into a single box.
Again, and so explain to me the components of the VMware Edge solution.
So this solution, in this solution we provide LTE connectivity. We use SD-WAN that's run inside the box. We provide edge computing services, so it can run VMs, it can run containers, and we also provide Wi-Fi connectivity for the whole truck.
Oh, so it'll connect with LTE, but then the Wi-Fi can be used around it for other devices.
That's right.
Okay.
So for some devices in the truck, for example, a body camera only works on Wi-Fi. So we record everything onto that single device, and then we can choose to stream it up to the cloud or keep it in the device for later use.
Okay, so now that I've got this connected law enforcement vehicle, right, with your stack, what are some of the things that police officers can do that they couldn't do before?
So they can deploy additional services like a dispatching program, for example, or collect telemetry in the car, whether the car is driving too fast, is cornering too fast, or you're chasing someone, right? All those programs can be run on that single box.
Okay, so it helps protect the officer.
Yes.
Well, yeah.
Yes.
Now I also see that you're doing some license plate scanning here. Talk to me about that.
So if you look at the truck, there's a 360 camera, and we deploy license plate reader for that camera. So whenever a police officer drives on the road, it scans all the cars around that truck, and it looks for things like stolen trucks, for example. If it identifies that stolen truck or car, then it's gonna pop up an alarm, so the police officer can deal with it.
Yeah. So is this for, when you think of the whole concept of the connected vehicle like this, is this something for law enforcement, or do you see other use cases for it as well?
Anytime you have a lot of services running in a fleet, for example, ambulances,
fire trucks,
what do you call it, Brinks trucks.
Oh yeah,
So when you have a lot of services running inside a fleet, you can deploy this service.
Okay, that's interesting. So, all right, anything else you want to share with me with the truck?
You can think of this as a server consolidation or service consolidation. If you think about the data center 10, 15 years ago, we consolidate a lot of servers onto a VMware infrastructure. Now we're doing it at the edge of the network.
So I've seen your GM Sanjay Upal talk about Honey, I Shrunk the Stack.
Yes.
That's in essence what you've done here, correct?
Yes.
Yeah.
So we shrunk the stack to optimize it for the edge.
Good. And so what's next? Are you working with other car companies in this area?
So we're looking, there's a lot of customers who stop by and want to deploy the service in their municipality.
Okay.
So we're going to work with them to deploy this to make it easier for police officers to have additional services not available before.
All right, Chris. Well, thanks for the demo. I guess when we think of branch offices, we think traditionally of buildings, but I guess the vehicle is now one, right?
Yes.
So, all right. Well, thanks for that demo. That was great.
All right.
Thanks.
Thank you.
All right. So I'm here at Saqeb Akhter, and we're at the manufacturing demo in the VMware Expo Hall. And this is another edge use case. So
it is, yeah.
Talk to me about what you're showing here, where all the components are.
Sure, we're actually talking about the future of manufacturing.
The future of manufacturing.
Yeah. So what we're showing here is how a virtualized PLC can actually drive the factory automation, right?
Okay.
So today there's a billion PLCs out there today, or programmable logic controllers, and they drive the factory process, and all of those today are hardware appliances or purpose-built hardware. Right.
Okay.
So
that's what this is.
No, that is not what this is. So it looks something like this, similar to what we have over here. But what we've done is we actually virtualized it, and we're running it on top of ESXi.
Okay.
Right? So what that lets you do is really get lifecycle management for that PLC. So imagine your purpose-built hardware breaks, and you have to order a new one, and lead times for PLCs are about a year long today.
Okay.
Right? So instead, with a virtual PLC, you can actually now run it as a VM, and you can spin up a new one whenever one of them fails or you need to expand.
And so the VMware tech is in this box here?
It is, definitely,
okay.
yeah.
Okay.
So ESXi gives deterministic networking and CPU performance to drive that PLC. Okay. So I'll actually show you how that works.
Right. So what is this demo doing here?
Yeah, so I'm actually going to simulate ordering something from the factory.
Okay.
So this is the factory inventory. It's showing the warehouse over here. So I'm going to order basically a white part, and it's going to run through the factory process. Okay. And it's all going to be driven by the PLC in terms of what it needs to do next.
So without the edge stack, what's the before and after? So what was the part of the process that was broken that required us to shrink the stack down to an edge? So
the real value that we're providing here is the virtualization stack over here, right?
Okay.
So beforehand, you had to have purpose-built hardware to actually run this, and anytime you wanted to do an update or upgrade these PLCs, you had to actually go to the physically to the factory, replace it or update it or do whatnot.
But now you can do it on the fly.
Now you can do it on the fly with vCenter or whatever operational.
And I'm guessing without that, the typical upgrade path with manufacturing organizations would be quite long. They would,
exactly, yeah.
Okay.
Long lead times to buy new hardware. Now it's all virtualized. You can actually get benefits of virtualization for a PLC.
Okay, so let's see.
Let me go ahead and click order here. So now that I've clicked the order button, it's actually going to walk through. It's actually going to walk through the pieces. One of these pieces, the white ones, through the factory process, and that's all being driven by the PLC itself.
Okay, and so this is fully autonomous now.
It is, yeah. And what that requires is really the PLC to have real-time networking and CPU performance, which is what ESXi is providing here.
Okay, and so how much? I know Sanjay Upal, your GM, likes to talk about shrinking the stack. How much? Give me a sense of how much the stack has shrunk from what the before and after would have been.
Yeah. So imagine you have a factory typically has hundreds of PLCs, right? So you imagine hundreds of these, right? Purpose-built hardware. Now you can shrink them down into a compute cluster.
Okay.
And not only run PLCs on that compute cluster, but other workloads as well. So you're consolidating all these other components you have at the factory into this general compute cluster.
Okay, so in an era where sustainability is important, companies are coming out with their long-term ESG goals.
Yep.
This actually plays a pretty big role in that
100%,
as well.
Yep.
Okay.
Yep,
so it's not just from a operational efficiency perspective, but there are other benefits.
It'll definitely save costs from that standpoint as well.
Yeah. And can you tell me about any customers doing this?
So we're working with Audi right now to bring this into production. So if you look up Edge Cloud for production, they're actually looking at this exact stack that we have here, testing it and bringing it to their factories in production.
Yeah, the thing I find interesting about the Audi example too is while you have a Ford that I just looked at, the Audi example isn't so much the connected car as it is the factory efficiency,
correct? Factory efficiency and operationalizing the PLCs there.
Yeah, and now this drives a lot of IT/OT integration as well, especially in a factory, right? And is the buyer for this your typical IT person, OT? Is it a combination of the two?
It's definitely going to be a combination. So if I look at the people that have come by the booth today, it's been both. Either it's the OT guy getting excited by looking at this, or it's the IT guy saying, hey, my OT guy might like this as well. And the idea around that compute cluster is that both can leverage that cluster for any workload.
And then how do I think about this as it relates to your data center strategy? From an operational perspective, are customers wanting to have that same operational model at the edge that they do in the data center?
Definitely.
That's the VMware value prop?
That is, yeah. So most of the people who have come by here, they want to be able to manage and operationalize their PLCs just like any other VM that they have at the data center. So they're pretty excited when they come and see this.
All right, so it becomes just another workload.
It does.
Very special workload.
Special workload.
All right, well, it looks like the demo's finished.
It did, yeah?
Yeah, well, thanks for that. I appreciate the time.
Awesome, thank you.
I'm here now with Ajitesh Gupta from VMware, and we are in the future of retail. So, which again is another great edge use case. In fact, I think you have a prepackaged retail offering, correct? So, talk to me about the challenges retail has and what you're demoing here.
Yeah. So there are a few challenges that we have learned talking to them. So very first one is how to run the overall retail operations more efficiently. And what I meant by that is if as a retail owner, if you are able to know the foot traffic, and if there is a way to predict the foot traffic ahead of time based on your past historical data, you will be able to run your operation much better. Because you know the Monday between 9 a.m. to 12 noon, these many people with almost 95% of accuracy can say this many people can visit on that day.
Okay.
And rest of the operational resources that is required to manage those many visitors will be able, you can just plan for those ahead of time. So that is number one challenge. Second challenge is the utilization of the space.
Yes.
In the retail stores, right? And when I say utilization of the space, it's not just the aisles, the corridors, your checkout, check-in points and all, but also the shelves where you already have the products. If there's an automated way of telling the store owner that, hey, you have hundreds of aisles, and these are the 15, 20 aisles where the utilization is more than 100%. And here are the 15, 20 aisles, the utilization is 10%, 12%. People are not going there.
Yeah.
Or even people are going, they're not stopping, they're not pausing there, they're just moving away. That will help the retail owner to better plan their aisles with the right products so that they can analyze why some areas are overutilized and why some areas are underutilized and how they can create a balance out of it.
So you could actually extend that to stadiums, hotel lobbies, anywhere with a lot of foot traffic.
Exactly,
right? Yeah.
Exactly.
So.
And the third thing is inventory management. And that's the most, that is the biggest challenge that every retail store manages. They do have the shelf space, and every shelf space is premium space for the retail owners. They want to make sure that its productivity is much higher. So products are getting in, products are getting out, and what happens is, in our solutions, what we are showcasing is how to manage the inventory in an automated way more smartly. If there are 10, if there is a one SKU, 10 products are there, and there is a way I can have the threshold that, hey, after the 3 items are left, the store manager should be notified through SMS messages or phone calls or email notification that, hey, right now there are only 3. Go and replenish it with few more. And if those things could be done in an automated fashion in less than a second, that is what our solution is all about.
And have you seen a lot of desire from retailers to want to move to that just walk out type of model where somebody just picks up an item, they walk out of the store and they pay for it?
Yes.
Yeah.
Yep.
Okay.
And there are two things that we are showcasing in this booth.
Yeah.
The very first thing is the infrastructure that is required to run this kind of computer vision application. And that is where the VMware private mobile network comes into the picture.
Okay. And so what do you have in here then?
Okay. So we do have the radio unit.
Okay. And that's a 5G radio?
Right now it is a 4G radio.
4G radio, okay.
But the VMware private mobile network currently supports both the 4G and the 5G.
Okay. So we're available.
Yes.
Yeah.
Yes. And then we do have 2 cameras over there.
Okay.
And just because we do have the private mobile network infrastructure, it's able to stream the video from the edge, from this side. This is more like a site for us. in a seamless way with the right amount of latency and throughput.
Okay.
We also have the user devices.
And what are those?
So user devices are we calling as CPEs, and we have a SIM card inserted into it. And that is another advantage that VMware Private Mobile Network brings for the enterprises. If any enterprise which is running on the Wi-Fi, then there is a certain degree of security challenges.
Yes.
But if
Wi-Fi is also very unpredictable. Sometimes it works, sometimes it doesn't.
Doesn't work, right? So reliability, robustness, quality of services, and the security, that's what the VMware private network, private mobile network brings to the enterprises with a pretty robust connectivity all the time.
All right, so you've got the cameras, the network up there.
And we do have a server running. In the server, we do have the VMware ECS, Edge Computing Stack. We also have the VMware 5G core running.
Oh, you do have a 5G core running. Okay.
We do have the 5G core running there. And these are the infrastructure, software applications.
So this is a complete edge stack deployment.
Complete, vertically integrated, validated PMN, the private mobile network stack that we have.
Okay. And then what's the demo you're showing here?
So right now we are showcasing two different use cases. The very first one is the retail store's visitor experience. So anyone who walks in, it just identifies, it counts the number of people. It also detects your mood.
So that's a real-time counting.
That's a real time. Okay. That's the real time one. So
how does it detect my mood?
Okay, so it's just your facial expressions and there are algorithms behind it, and that's how it does that. That is number one. And the second one is the inventory management. So let me just go and change it. Okay, so this is we are simulating the shelves from any retail stores. So why don't you just go and pick up any one of the items?
All right, what do I want? I'll grab some coffee.
Okay, so let's see what happens now, because now it's empty.
Yeah.
Okay, so detected the empty, and there is a notification, new notification that came.
Oh, that's right. That was very fast too.
Yes,
okay.
yes, and it says that hey, your Starbucks coffee is stock out.
Yeah, and then that message gets sent to somebody, I assume.
Yes, yes. So we can configure that if that message needs to be sent someone as a text message, that message can be sent as an email to someone, one person, multiple people. That is possible.
And so without that, you basically have to wait for a customer to complain. Somebody have to run back and see if there's inventory, then come out and restock the shelves.
Exactly.
Yeah, so it's good. Okay, good. Well, that was a great demo. So what's coming next year?
Okay, so next one for us is to extend whatever currently we are doing. So for example, right now we are showcasing the retail analytics solutions for any kind of retail stores, how the future of retail looks like. Now, the use cases, there are two different aspects of it, right? One is the VMware private mobile network, and we are going to extend it for some new features out of it, right? That is one aspect of it. For example, we do have a one radio from Airspan, our partner.
Okay.
We can have more number of radio partners with us. For example, CommScope access point that may come, and it can come any new radio vendors too. So we will keep on increasing our radio portfolio as part of our private mobile network. And the second one is we do have something called private mobile network orchestrator. So what PMN orchestrator, we call it PMN orchestrator, what it does is it helps any one of the enterprises to onboard the PMN infrastructure in few hours. So ease of onboarding, ease of operations for the day 0, day 1 and day 2 activities could be automated, and in a way for any enterprise that they don't need to know the technologies. They don't need to understand how radio works, how core works, how telecom works. The way we have designed the PMN orchestrator, it is more intuitive, and even if you know a little bit about the IT, you will be able to use it as a user. So that's one. On the retail side, we are also trying to see how we can add more use cases. For example, if an accident happens in the retail stores.
Right.
Right, people fell down.
There's legal issues.
Legal issues are there. Some people are bringing something that you don't need to know. Your capacity management of the retail stores. How do we make the parking spot more smarter? That someone comes in the parking lot, the parking have enough space in terms of the capacity management. Any unwanted events are happening in the parking station, because store manager most of the times are inside the store. So if there is a way something is happening that our store manager needs to know, that could be done also as part of the retail analytics use cases.
All right, well, thanks for that demo. That was a fascinating demo. I really enjoyed that.
Thank you.
Thank you very much.
Thanks.
All right, well, I'm here at the other side of the future of manufacturing demo here, and I'm here with Mike Wright from VMware. I've got a kind of a cool looking arm, a deck of cards. What are we looking at here, Mike? Tell me what this demo is.
Yeah, so this is a small representation of process automation assisted with AI computer vision inferencing. Okay. So what we want to demonstrate here is the ability to improve process quality, manufacturing with the help of AI, and specifically computer vision, right?
All right.
So this walks us through the process that we are going through here, where it starts out with training a model. And training a model is CPU intensive, is GPU intensive. We do that in a data center. We've got plenty of compute resources where we can accomplish that. The challenge is we want to take that process, that inferencing, and put it down in a manufacturing location on a small industrial device.
Because that would normally take a lot of equipment.
Yeah. Normally would take big stacks of servers. NVIDIA GPUs were pretty pricey, potentially. So how can we shrink this down and put it on a more affordable industrial PC? That's kind of the goal here.
Yeah.
So this just walks through the process of developing this, where train the model, develop the Python applications, manage the workloads and the device itself at scale, because we might have thousands of those devices, and be able to convert that workload to something that can run effectively on an Intel-based processor without a GPU. Then control robotics or influence robotics controls by the inferencing that comes from the AI, right?
So the cost implications of this are huge.
Yeah.
And typically, without being able to shrink that down, where would you do the training and?
Well, yeah, I mean, training models and doing inferencing is process intensive.
Yes.
So there's a hardware requirement, and then there's also right-sizing the software element that does that processing.
Okay.
And so it's a combination of doing the training on large, heavy equipment, processing with large data sets. In this case, we're doing blackjack as the input to the camera. So 2,000 cards took 4 hours to run the model, train the model on an NVIDIA-based environment. This horsepower is much lower when we get out here.
Right, so if you try to do the training on that you said 4,000 hours? No, 4 hours?
4 hours for 2,000 sample images.
Okay,
right.
Without the GPUs, that would take
weeks.
Months
right,
maybe, right?
Right.
Yeah.
And the other part of it is we can do the training in data center, but inferencing is what we want to apply at the field, at the edge.
Yeah.
So we convert it using the help of Intel technology called Intel OpenVINO. And they've come up with a process that can take trained models that were produced from an NVIDIA-based environment, big CUDA-based environment, and run that efficiently on an Intel-based environment.
And so this little Intel box is the computer now?
That's the computer.
Okay.
And that's running ESX and a lightweight Kubernetes that we provision with something called Project Keswick.
Yes, you announced at the show yesterday.
That's right. New technology, Project Keswick, allows us to do GitOps deployment and lifecycle management of that small device times 1,000. Okay. So gone are the days of a VI admin that has to come in and configure that. We just ship the device.
And this can be managed remotely as well.
Yeah.
Okay, so if you have to do an upgrade over the air.
Right.
Okay.
Right. And we're going to have two models. We're going to start out with a SaaS-based control plane to manage thousands of these hosts, and then also develop the on-prem only for private data centers, so that customers who don't want that stuff going out over.
Yeah, and do you have a sense of customer preference, or more choose the SaaS model?
We get both. Some of our bigger manufacturers are concerned about IP.
Yeah.
Because that camera feed is looking at things that are happening inside of a private manufacturer. And it's not that we're sending those frames up to our SaaS control plane, it's just more of the policy. Everything has to be behind the firewall.
I got it.
Right. But then there's others that are these lighter weight scenarios where an oil rig is somewhere out in a field or across the Gulf of Mexico, and you've got to go over a satellite uplink, to manage those things potentially.
You don't have a lot of bandwidth there.
Yeah, exactly.
So let's see the demo.
So the demo, okay, so in this case, I'm going to switch over to the view here. What we've done is we've built a couple of microservices. Now, on the whiteboard here, we explained that we've got a front-end microservice and a back-end microservice, and then in between, we've got something called RabbitMQ.
Okay. RabbitMQ.
Yeah, so the back-end process is the part that does the inferencing. So it's going to read camera input and run the inferencing on whatever it gets off the camera, and the results of inferencing is going to be pumped to the front end via RabbitMQ. Okay.
All right.
So when I start this up, I have to start the back end. So we've got a back end process here that starts up the inferencing. Now in production, we would have this, all this startup would be automated.
Yeah. But this is just a Python script.
It's just Python. It's running in a container in Kubernetes. I happen to have a GUI. I'm using Jupyter, which is common amongst data scientists, to drive the demo. So we've got the back-end process started, and it's ready to start inferencing and sending that result over RabbitMQ. Now I come over to the front end and start this whole thing up. This will get our game going. So in an industrial setting, this code would be not playing blackjack, obviously.
Yes.
It would be making decisions or adding input to the robotics so it can maybe make adjustments.
But it's a good example where you need computer vision, you need to grab objects, things like that. Yeah.
Right. So right now the camera is inferencing. It detects that there's no cards in front of it.
Okay.
So the camera stands up and says, we get a little bit of output up here. Let's play some blackjack, right?
Okay.
Now, like I said,
Yeah.
inferencing is imperfect. So the scoring we get on the inferencing is critical. So if I get confidence from the inferencing that it's at a certain threshold, then I can translate that I believe that I have this card. So in this case, you see up here, 10 of hearts, and it's saying hit me. That was the motion there to the dealer, hit me, because we're scored at 10.
Oh, ooh.
Perfect card. We have a good chance of winning here. So hopefully...
Not at the casinos I play at.
Yeah. It depends on how much martinis this robotic arm has had. But it sees that it's a king, and it calculated that to be a 20. So now we're saying hold right there.
Wait, it's ace count. It's counting cards.
Don't say that too loud. So one of the things I wanted to show you here behind the scenes.
Yeah.
This is kind of difficult because, well, I'm getting 70% confidence on that 10 of, well, it's calling it 10 of clubs. So inferencing is messing up the suit, and what that tells me is my data set isn't as good a representation of this environment.
So further training is needed.
Further training is needed. So that we're back to that wheel and we go back to the data center.
Yeah.
So that's
an interesting aspect of AI. When it makes mistakes, people lose confidence, and I always tell them, look, bad data, bad inferencing is okay because it becomes part of the data set and it makes it better over time.
Right, right. So it's an iterative process. Yeah. What I would do is take maybe hundreds of pictures of these cards in this environment with this lighting, and then add that back to my data set in the data center and retrain my model.
Okay.
And so that cycle, we want to support that entire cycle of ML ops, DevOps, GitOps for workloads that are running down in an IPC in a manufacturer. Yeah. So that's essentially it. We're calling this Edge AI for the Edge team, and we have a lot of work ahead of us. But it is being based off of this new technology that the Edge team is developing, Project Kesset, for onboarding this device and doing GitOps deployment of those app workloads out to those devices.
All right, so that's fascinating. So in essence, this is what VMware does, right? It takes workloads and abstracts them from the underlying hardware, and it makes them more usable in more places. So in a sense, this is a very unique workload, and that it involves AI, computer vision, things like that. But it is something that VMware historically has been doing.
Right, and we want to consolidate workloads on the smallest device we can. So the traditional value prop for VMware is bring all the workloads together on a shared infrastructure in a data center. Well, in Edge, we're talking about hundreds or thousands of sites, locations, but we still have the consolidation problem that we want to address there. VPLCs on the other side, Edge AI, legacy app workloads. bring that all together in containers and VMs and shrink it down as much.
But this could be something simple as a Raspberry Pi or something, right?
Yeah, Raspberry Pi is based on ARM. We're keeping an eye on that market. You know, typically
these are
that's
Intel. Okay.
What's that? That's Intel based. Yeah. So on the other side, we have an Advantech Intel-based industrial PC. That's kind of more what we'll see in the manufacturing environment, but still with the integrated GPU from Intel. Same exact process, same, bigger robot, better cameras, more cameras in a manufacturing site.
Well, the fact that you can do it on that device, to me, is remarkable. So.
Yeah.
All right, Mike. Well, thanks for the demo.
Yeah,
was good.
no problem. Thank you.
Best of luck playing blackjack. Maybe you can bring this guy with you to the table.
Yeah, that's what I'm hoping for.
Okay.
I'll put it in a little costume next to it.
Okay. Thanks. All right, well, that's a wrap on this ZK tour. We saw lots of great demos of edge computing use cases. We saw 2 manufacturing, the Ford pickup truck, and retail. So I hope you enjoyed this ZK tour, and I'll see you next time at another event.